The next functional group I want to look at are alcohols. Alcohols are simply where you replace a hydrogen by an OH group. So if we think about just normal alkanes, alkanes are CnH2n plus 2. Replace one of those hydrogens, we get CnH2n plus 1, OH. Now you will notice, I hope, that the actual number of hydrogens hasn't changed. So we could write the alcohols, and we will occasionally do this, as CnH2n plus 2, O. Having an oxygen in there doesn't mess around with that alkane formula in the same way that having an extra carbon-carbon double bond, or having a ring, or as we'll see later on, having a nitrogen will do. Now the simplest alcohol is of course CH3OH. We'll draw it like that, so there's just the carbon bonded to an OH, so effectively aligned to OH. The smaller molecules really don't look very good with these skeletal structures. It is of course a example of a primary alcohol. You might actually say it's a methyl alcohol, and indeed that was the original name for it, methyl alcohol. Then of course things changed to where instead of having that methyl alcohol and so forth, you just took the regular old name for the number of carbons and added an ol to the end of it, so methanol. Next one of course therefore with 2 carbons, so here we are, CH3CH2OH. There's the skeletal structure of it, 1 carbon, 2nd carbon bonded to the OH. Again, this is a primary alcohol, and this used to be called, and still is by some people, ethyl alcohol, or of course the more familiar name, ethanol. Now when we get down to the 3 carbon alcohols, there are 2 possible isomers. So there's our normal old propane, 1, 2, 3, 1, 2, 3. We can put the OH on the 1st carbon or the 2nd carbon. When we put it on the 1st carbon, it makes a primary alcohol. On the 2nd carbon, makes a secondary alcohol. And so the very old names, propyl alcohol, and then an isomer of that, or isopropyl alcohol. And those of you who've been following my use of some of the older trivial names for branches will recognize this indeed as an isopropyl group. Now this of course meant that when they first of all re-looked at getting a standard naming, you have to of course put the number of the alcohol, which carbon atom the alcohol is on. So this one here will be 1 propanol, otherwise known as N-propanol, and this one here will be 1,2-propanol, otherwise again known as isopropanol. Now that was how it was when I was learning how to number these things, and then it got changed up a little bit so that instead of putting the number before the whole thing, it actually got put right before the ol. So that new numbering wasn't methanol, ethanol couldn't change, but then it was propan 1-ol and propan 2-ol. So we got 3 types of naming that you need to recognize. There's the old-fashioned, which again you will still hear, where you just put the name of the alkyl group in front of the alcohol. Then there's where if you need a number, you put it before the alkyl anol, so 1-propanol. And then of course there is the where it comes in the alkyl an, then the number, then ol. Remember, you do need to be familiar with all types of naming of compounds, and alcohols, as much as any other group, suffer from having trivial names. Alcohols and acids have those really trivial names. Just to emphasize this naming and also show you that as well as primary and secondary alcohols, you can have tertiary alcohols, I want to take a slide to look at a butanol, C4H9OH. Now as soon as I say butanol, you know it's got 4 carbons. The anol tells you that one of the H's has been replaced by an OH, so it's C4H9 instead of C4H10, C4H9OH. Now of course you can have the usual straight chain isomer, so 4 carbons in a row followed by OH. That of course is N-butanol or butan 1-ol, and it's a primary alcohol. Then of course we can put the OH on the 2nd carbon, so that would give us sec-butanol using the old naming, or 2-butanol or butan 2-ol, depending on which of those newer fangled names we're using. And of course this is a secondary alcohol. And again, going back to the naming of those other groups, you might recognize this as being a sec-butyl group, so sec-butyl alcohol or sec-butanol. Now there's another primary alcohol, which is where we take a 3-carbon chain, stick a methyl off it, and put an OH on the end. So you might notice the same skeletal pattern here, except we've moved where the OH is. So naming that would be isobutanol, because here is the isobutyl group, or 2-methyl propan 1-ol. So the propan 1, 2, 3. OH on the end, as we'll see in a minute, wherever the alcohol group is that dictates the numbering and the chain to be picking. I'll point out in a minute that so far of all of the groups we've looked at, the alcohol has the highest priority. Anyway, what kind of alcohol is this? As I said earlier, it is a primary alcohol. And then finally, one of my favorite alcohols, you might remember this one here. This is a Tert-Butyl Group. Tertiary butyl group. It's butyl with a tertiary carbon in there. So tert-butanol is the old name for that, and indeed the new name, current name for a lot of people. Or of course you would call it 2-methyl propan 2-ol, and that is an example of a tertiary alcohol. Just to emphasize the priority of alcohols over alkenes and then halides or alkyl groups. If I had this molecule here, it might be tempting to start numbering up this end because the Cl will be at number 2, the OH not until number 3. The OH is more important than the Cl, the OH dominates it. Thus it is 6-chloro-heptane 3-ol. Let's make sure we get where that is. 1, 2, 3, 4, 5, 6, 7 alcohols, 7 carbons, excuse me. So therefore the alcohol is off the carbon number 3 and the chloro is off carbon number 6. It is not 2-chloro-heptane 5-ol, even though of course these have smaller numbers, the alcohol dominates. The alcohol also dominates over an alkene, so therefore this molecule here, we got 1, 2, 3, 4, so it's a bute. We got an alkyl group, we've got an alkene. This will be bute 3-ene because the alkene starts at the third carbon, 2-ol, because the alcohol is at number 2. It's not going to be bute 1-ene 3-ol, even though again that would give our numbers and that make lower numbers. The alcohol dominates over the double bond. Now this molecule here, some of you will have noticed that this carbon 2 has got 4 different groups at it. It's got a hydrogen, it's got a methyl group, it's got an OH, and it has this carbon-carbon double bond. Worth quickly looking at the CIP rules for this and also practicing drawing our enantiomers. So as I look at this, the top priority is going to be the oxygen. Alcohol always has a top CIP priority over alkyl groups. That's number 1. Hydrogen always, of course, poor old hydrogen, number 4. Bonds to the carbon. This carbon effectively goes to 2 other carbons and a hydrogen. This carbon just goes to 3 hydrogens. So the alkene group, number 2, methyl group, number 3. Now if I draw it out, I can put my hydrogen at the back, put the methyl, the alkene, and the OH pretty much just in the order I have it here. If I draw the mirror image of that, there is the mirror image. Okay, imagine a mirror plane here. So the alkyl group first, methyl group on top, OH is coming out at you, hydrogen going away from you. Practice assigning this. So in this left hand one, we have the OH is number 1, the double bond is number 2, methyl group number 3. How did we do that? We went anti-clockwise, which makes this the S enantiomer, and this one here, in order to count it, we go from the OH to the double bond group to the methyl. We're going around clockwise, and so that makes that an R. So a few extra little things associated with naming alcohols.